reading graphs of f prime. So it's another big one that's actually shown on the multiple choice and the free response a lot. The key thing about this is knowing your definitions, right? I have the f prime graph, right? So this is the derivative. So all the stuff I can read from here to this, right? Where it's positive, it's increasing. F is increasing, I should say, not it. F is increasing. Where it's a negative, F is decreasing. Where it equals 0, F has a critical point. It could be a max or min, depends, right? If you go from positive to negative, it's a max. If it goes from negative to positive, it's a min. If it doesn't change, it's neither. Right? All that tells you all that stuff. So we know all this stuff, right? Because we have the first derivative, so it tells us all this stuff about f. The hard stuff is when they ask us stuff that has to do with the second derivative, like concavity and inflection points. So the second derivative, the trick to doing that is don't think about it as like concave up, concave down. Remember, you have f prime, not f double prime. You gotta think about its derivative. F prime is the derivative of f prime. So what does that mean? When f prime is increasing, f double prime is positive. When f prime is decreasing, f double prime is negative. Right? So where this graph is decreasing, that means its derivative is negative. Where this graph is increasing, its derivative is positive. When f prime has a max or min, that means f double prime has a critical point, which for f double prime means an inflection point. So if I was looking for the inflection point in my original graph, it's where this graph has the min and max. Right? So that's a tough one. The toughest part is when you have f prime, when they ask you questions about f double prime, you gotta keep in mind the key thing is f double prime is the derivative of f. So that means where it's increasing, decreasing tells you where f double prime is positive, negative. Where it has a max and min, it means f double prime is a critical point or an inflection point, right? So this stuff's generally easy. If they ask you about f prime stuff, easy. Increasing, decreasing, just look at it, right? Where does f increasing, decreasing at? Just look at the graph. When they ask you about f double prime stuff, concavity or inflection points, you gotta think, okay, I gotta look at where the derivative of this guy. So I gotta think derivative of this guy. So increasing, decreasing, and min max. So let's do a couple of questions. So here's this from 2007. Let f be a function defined on the closed interval -5 to 5 with f of 1 equals 3. Oh, that's an initial value right there. And that's actually something I forgot up here, right? If they want to find a value, it's very, very important. If they want to find like f of 3 or something like that, like you have f prime, how are you going to find f of 3? It's always the same thing. It's a form we've been using a lot. You do the initial value with respect to y plus the integral from your initial value of x. So the thing you want, integration f prime. Remember, in this case, this is just in the area. That's all it is. So like if I said the initial point, if I said like, hey, f of 1 equals 7, the way I would do f of 3 is this. F of 3 would be 7 plus the integral from 1 to 3 of f prime. And all I do here is find the area. And yeah, that's a 7. So it's a very big concept, very important concept that happens when you have f prime graphs. So let's go down here and do this problem. Okay, so that's what that's about. Here's some line statements. So first, for f -5 to 5, find all values which f has a relative max. Justify your answer. Oh, it's starting off with relative max already. So remember, relative max, not that bad. The way you find a relative max, that's where f prime equals 0. So I have my graph here. Where does it equal 0 here? It equals 0 there, there, and there. Positive, negative is a max. Negative, positive is a min. Positive, negative is a max. So I have it at x equals -3 and at x equals 4. Why? Because you go from positive to negative. And there you go. That's it for A. B. From -5 to 5, find all points of inflection. Justify your answer. So now this one's tougher. Points of inflection when the second derivative equals 0. Again, I have the first derivative, so you also got to know that means when the first derivative is a min or max. right? So again, they want the second derivative. I have the first derivative. You got to keep in mind that's when the first derivative has the min or max. That's how you find the second derivative equals 0. So in that case, that's at 4, negative 4, sorry, at negative 1, and at 2. Do they all change signs? Yes, they do. So those are my inflection points. And then how would I say? I'll just say f prime has a min or max. Relative min or max. So that's B. C, final inverse on the graph in which f is concave up, also has n also has a positive slope. Explain your reasoning. Ooh, a couple things here. So concave up means the second derivative equals 0. Is greater than 0, sorry, it's positive. Now the problem is, again, I don't have the second derivative, I have the first derivative. So you gotta keep in mind that, how do you find that? That also a way of saying it's the derivative of f prime, so that's where f prime is increasing. Right, so where f prime is increasing, its derivative is positive. That's what we're looking for. So second derivative equals 0, this means the first derivative is increasing. And it also wants to know what, when the slope is positive, has a positive slope. So where f has a positive slope, that's just a fancy way of saying f prime is positive. So let's tackle these both ways. So let's do increasing first. So this is increasing from here to here. And from here to here. And from here to here. Right, that's what's increasing, like going up. Where does it have, where's that prime positive? It's positive from here to here. And positive from here to here. Right, where it's above the x-axis. So it wants to be above the x-axis and increasing. So the negative 5 to 4, and then 1 to 4 will be my answers. And then you would say because f prime is increasing and f prime is greater than 0. That'll be the reason. So again, kind of tough, right? Positive slope just means f has a positive slope, that means that the derivative is positive. I have the derivative, so where is it positive? Here and here. In concave up is a fancy way of just saying, in this case, f prime is increasing. So you have to figure out what's increasing. So tough one, but that's the idea. And then D, find the absolute min. So now we have the absolute min. Again, absolute min and max never changes. The way you do it's always the same. You do critical points plus endpoints. Endpoints they give me, it's negative 5 to 5. I gotta find the critical points. That's where the derivative equals 0. I have the derivative on me, so the derivative equals 0 at negative 3, 1, and 4. Now I am looking for absolute min, so I really want to check the one that goes from negative to positive. So all I gotta check is 1. Again, you can check all of them if you want, but they want the min. So the min's only give me a heaven at 1, so it goes from negative to positive. So I'm gonna put x equals 1. Now I gotta check which one of these is the min. Now this goes back to the equation we did earlier. If you want to find a value, it's the initial value plus, right? If you want to find a value of f and all you have is f prime, it's the initial value plus the integral from that initial value to that number you want. So if we're doing this one, let's start with x equals 1. It's going to be, if I want f of 1, it's going to be an initial value, which they gave us up here. 1, 3. So again, the y value goes first. I'm going to go 3 plus the integral from 1 to, well for me, 1 of f prime. So that's just going to be 0, so 3. If I want f of negative 5, it's going to be 3 plus the integral from 1, sorry I messed that up, to negative 5 of f prime. This is just area, so I got to flip this, so that's going to be the same thing as saying the negative of from negative 5 to 1. Negative 5 to 1, that's pain. It's going to be those two half circles. So pi r squared divided by 2, so 1 pi r, so this pi r squared. It's like this one's just, this, we're doing the last problem, so I write it here. Pi r squared divided by 2, so that's just going to be pi over 2, because r is 1. This one's a negative thing, because it's below the x-axis, and the radius is 2. Yeah. So negative pi r squared, 2 squared, divided by 2, so I'm just going to get negative 2 pi. So pi over 2 plus negative 2 pi. And then all that has a negative on the outside. So I have 3 plus negative pi over 2 plus 2 pi. And then so if you simplify, you get negative 3 minus pi over 2. Oh, this would be negative 2 pi, right? Plus pi 2 pi. And if you're trying to figure out which one's smaller, this is like 6. This is like around 6, right? Because 3.14. This is about 3 divided by 2 is like 1.5-ish negative, and that's 3. So it's like 8. So it's pretty big actually. And then we still got to do f of 5. So let's do f of 5. F of 5 is going to be the integral from initial value, which is 3, plus the integral from 1 to 5. So the integral from 1 to 5 is the area of that triangle. So 1/2 base times height. So 1/2 4 times 2. So that's just going to be 4. And then minus the area of this triangle. So that's what, 1 and 1, so 1/2. So 4 minus 0.5, so 3.5. So this is going to be 3 plus 3.5, which is going to be 6.5. So my min is 3 at x equals 1. And what do they want? Find absolute minimal value, explain your reasoning. So again, reasoning is just your work. And the minimal value we got was 3. So the answer is just 3. Not x equals 3, just 3. Right? They wanted the min value, not where it happens at. Okay, so there's that one. I think we'll do one more, and then we are done with APF, with reading graphs of f prime. Let g be a continuous function with g of 2 equals 5. So again, they're giving us initial value, so they're probably going to ask us to find a g value, like what's g of something, right? And we use that to help us. Graphs of piecewise linear function, blah, blah, blah. Derivative of g is fine. Find all the x coordinates of all points of inflection on the graph from there to there. Justify your answer. So again, inflection points are tough. Inflection points are when the second derivative equals 0. I guess we're doing g in this case. Or undefined. Now, I don't have the second derivative, I have the first derivative. So you gotta think back, okay, how do you get that from there? It's where g prime has a max or min. So where does g prime have a max or min at? Right here. And right here. So you're gonna say at x equals 1 and x equals 4, because g prime goes from positive slope to negative slope for the first one, and then for the 4 it goes from negative to positive. Slope. I guess you could say increasing and decreasing. It's probably the best. So actually let me erase that. That's the best way to answer that, is of y. And positive slope is just increasing, negative slope is just decreasing. So the reason why is this goes from increasing to decreasing. This guy goes from decreasing to increasing. So again, right, you're trying to find where the second derivative equals 0 and to find inflection points. You don't have the second derivative, you have the first derivative. So you gotta keep in mind, it's, oh, how do I do that? It's when the g prime has a max or min. So there and there. And you know what's your reason for it? It has a max or min, which means it goes from increasing to decreasing. So all that. B, find the absolute min value. So it's not starting off slow, are they? So absolute min, right, we need critical points plus endpoints. Endpoints, they gave us negative 3 and 7 to 3. Critical points is when the derivative equals 0. So you look up here, what does it equal 0 at? It equals 0 at negative 1, at 2, and at 6. But again, I want absolute max actually. Absolute max. What absolute max? This is a min, negative, positive. This is actually the max. Positive, negative. That's a min. So I really only need to check this 2. So I gotta check 2. Remember the way we check these things? You go back to the original equation. So if I want to find g of 2, its initial value, plus the integral of the initial value. It's the thing I want of f g prime, I guess. So in this case, my initial value was 2 and 5. G of 2 equals 5. So to me, g of 2 equals 5 plus the integral from 2 to 2 of g prime of x. This is just 0, so I just get 5. They also just told you g of 2 equals 5, but whatever. And g of negative 3 is going to be 5 plus the integral from 2 to negative 3 of g prime of x. So again, another one we have to flip that because it's going the wrong way. So it's going to be 5 plus the integral or I should say 5 minus integral from negative 3 of 2 of g prime of x. Negative 3 to 2, so from here to 2, so area of that triangle, which is negative, area of that triangle, which is positive, and area of that triangle. Actually, the whole triangle right there. Let me do this quickly. That's 1, 2, 3 times 1, so that's 3 over 2. This is 2, and you go down 4, so negative 4. So I get, let's say, 1.5 minus 4. So negative 2.5. So this is 5 minus negative 2.5. So 7.5. We got a new leader in the max department here. So now I gotta do g of 7. So that's gonna be 5 plus integral from 2 to 7 g of x, g prime of x. From 2 to 7, well, that's not gonna work. You get what? Negative 1, 2, 3, 4 times 2, so negative 8, negative 4 plus a little 1, 1, so 1/2. So negative 3.5, you do that all correctly, so you can get 1.5. So the winner, absolute max, is 7.5. Find the average rate of change from negative 3 to 7. So remember, average rate of change is a fancy way of saying slope. It's all average rate of change is. Instantaneous is derivative, average rate of change is a slope. So we're just going to find that from 3 to 7. So for C, we're just going to find the slope from 3 to 7. So 7 minus g of negative 3 over 7 minus negative 3. So now look, we already did these. This was it 2.5? G of 7? 1.5? G of negative 3 was our max, which was 7.5. And then down here, the negatives get positive, so I get 10. On top, I get 1.5 minus 7.5, so 6, negative 6. So negative 3/5. That's my rate of change. D, find the average rate of change of g prime on the interval negative 3 to 7. Does a mean value theorem apply on through negative 3 to 7 guarantee a value of c such that 3 to 7 dot such that g is equal to this average rate of change? Why or why not? So let's do the average rate of change of g prime first. So it's slightly different. So g prime from 7 minus g prime of negative 3 over 7 minus negative 3. So g prime of 7, it's actually a lot easier. So let's go to 7, and then g prime, we have g prime. It's just a y value, 1. Like, we literally have g prime, so it's just 1. G prime of 3, we have g prime again. So it's negative 4. From right there. So I get 5 over 10, which is 1/2. So that's my average rate of change with g prime. Now they want to know, does the mean value theorem hold for guarantees such that g double prime of c is equal to the average rate of change? Why or why not? So here's the thing. It's going to be no. Why not? I can tell you why not right now. So we're talking about g. Here's g, and we're going to take a derivative of that. Mean value theorem only holds when it's continuous and differentiable. Look at this. This is not differentiable. I can't take a derivative. This thing just like cuss everywhere. There's corners everywhere. So no. Not differentiable. And that's it. And that's it for this lesson.